And welcome back. Now today we're going to be having a quick update on this board here that I got from Dr Peter Dalmaris' book. Do you remember? KiCAD Like A Pro it's called. Very good book it is too. So I took his example, made a few changes on here and decided to build up the project mainly to get me up to speed with surface mount technology. I did chicken out a little bit, so these components down the bottom here, you see, resistors and capacitors, I decided to change those to through-hole components because I thought, let's not make it even more difficult than it has to be. So without further ado, let's just see how far I got along the way then with this. Obviously you can see it built up now, but obviously there were stages along the way. So let's have a look at that first and then come back to this afterwards. I'd like to give a big shout out to PCBWay, who are celebrating their 5th anniversary. And let me draw your attention to a special offer they've got at the moment. $30 for the assembly of your PCBs, up to 20 PCBs. $30. That's a real good offer. To celebrate, they've got a lucky draw, 50% off their gift shop and coupons. There's a coupon here for everybody. Have a look. And look, I'm wearing their 5th year anniversary badge. Ordering via PCBWay is easy. Just enter the dimensions of your PCB here and click the Quote Now button. Here you'll find all sorts of options for your PCB. I actually left mine entirely as default and it worked beautifully. I ordered on a Thursday lunchtime and by Monday lunchtime I had the actual PCBs in my hand. How about that? That's with DHL shipping and there are many other options available. If you haven't taken the PCB plunge yet, maybe now's the time with PCBWay. Go onto their website. It's easy. Have a go. So this is where I've got to so far. Obviously this is an interim bit of the video that I'm going to slot in. So as you can see down here, I've managed to solder that board partially and I've uploaded the bootloader and modified the blink program so it flashes twice. So you could say success. Sort of. Okay, let's take a step back then. If you remember when I decided to go down all this PCB and SMD route, I thought I'd get a couple of boards from Banggood just to practice with. So this was the board, or one of the boards anyway, that I bought. It doesn't actually do anything. It really is a test board. I thought perhaps it was an old kit or something, but no, it's a real test board. So I managed to solder a couple of chips. If you look at the soldering on that one there, it looks pretty good. Yeah, a few components, and I've done some other stuff on another board as well. So I thought, fine, it's time to have a go at the real thing. The real thing being this board here from PCBWay. If you remember, I had this done a little while ago, and it's a modified board from Dr Peter Dalmaris, who writes the KiCAD Like A Pro book. Okay, so he had this circuit. I modified it a little bit. One, to have a USB socket on it for powering it up. So what that means is over here, instead of just a 2-pin header, I've actually got a little tiny USB socket, but only for power, not for signal, which in hindsight perhaps wasn't the best idea, but anyway, it's just for power. I've changed a few of these components down here to through hole rather than surface mount because I was getting worried that I wouldn't be able to do it. This is before I did the Banggood test board. And what else did I do? I can't remember now. There's something else maybe. Anyway, the point is, I had this made by PCBWay, and as you can see, it's fine quality indeed. That's the front and the back. Yeah, it's all very nice, isn't it? So the one that I've soldered then is here, and if you've ever seen bad soldering, this is it. I mean, that chip, which isn't a million miles away from the chip on the practice board. So if we look at the practice board chip, in fact the practice board chip is, if anything, is slightly bigger. Same pitch pins though. This one went swimmingly well. I watched a couple of YouTube videos, saw exactly how I did it. It just worked. I thought, great, I've cracked it. And then I tried this one here and it was awful. For a start, having soldered it on there once, it was all misaligned and I couldn't get the solder bridges off, more to the point. So I had to use my new trusty heat gun, this thing here, to heat it up and take it off with my new ESD tweezers. These are from Banggood. There's a whole set of these tweezers actually, and jolly useful they were. In fact, I'll show you the set. There's a whole set of them. I can't remember how much they were now, to be quite honest, but I thought I've got to buy these, so I did. I'll put a link down below in the video eventually. Anyway, so having taken this off not once but twice because it was so rubbish, I eventually managed to get it on and put a different solder tip on my iron and used that, and then things went better. Now if you look, I'm going to try and get as close as I can in on here, because one of these sides on the chip is soldered pretty good. It's probably that one there actually. That one's not bad on the right. So that's pretty good, but the others, they're just rubbish. They've got far too much solder on for a start. Maybe I've put the solder wicking on this side but not the others, and I daren't. Having got it to this sort of stage, I thought I'm not taking it off again if it doesn't work. So I've left it and just soldered everything else that I could just to get it going. So I'm suspicious, I have to say, with the new solder that I bought. Now I use 0.7mm solder normally for everything, and it works like a dream, and in fact that's what I used when I did the practice board. And then I read somewhere that you should really go down a level, you know, 0.5, 0.4 or something. So I bought some of that, and I wanted leaded solder, not lead free, because lead free for hobbyist use is just too much hassle. Basically, it doesn't melt and doesn't wet and just doesn't work as well. And I'm, even though it says on the solder spool that it is lead and tin, yeah, well maybe I'm wrong, but there's something dodgy about that solder, and once you've got unleaded solder on here, well, all hell broke loose really. Well, I say it's unleaded. Whatever that solder is, it's different to that 1mm solder, no, 0.7mm solder I've got, and it just wasn't nice. Yeah, so yeah, now the USB socket up there, look, you can just make it out. That's soldered pretty well. Now the way I had to do that is to solder it in place, and then of course it bridged all the things, and then use some solder wick to get it off, and it cleaned it off quite nicely actually. So having got those two on, which were the difficult bits as far as I was concerned, I then soldered all the surface mount, all the through-hole stuff, which was such a relief to do, so easy to do as well for me. And I thought, well, I've got to power it up now and see what happens, and lo and behold, it's great. Now, because I didn't put any kind of USB to serial chip on here, so this USB is no good for as far as the data is concerned, you have to power it up and program it using, well, there's two ways of doing it. You can either use an Arduino, which is a bit of a faff really, quite honestly. I tend to use this, well, I was going to say FTDI, but it's not. It's a USB ASP version 2. You can see it's upside down there. But it's so easy to do really. There is one caveat though when you use this, which I'd actually forgotten about. And there's me pressing upload, and it goes, no, I can't get onto COM15. I'm going, but you shouldn't be trying to get onto COM15. You should be using this. What's going on? So let me show you exactly what you need to do if you are going to get one of these. And quite honestly, I recommend that everybody has one of these, so you can program through the ICSP connector for moments when you can't use the standard USB socket. And of course, if you've got a standalone Arduino or Nano or whatever it is, well, 80 mega 328p chip, then this is the only way really to do it. So let me show you the sketch that I use, more to the point, the mechanism for getting that program up there without using the USB port. Right, so this is the sketch. It's just a blink sketch, okay? I've modified it a tiny bit just to put a double blink in, so I made sure it really was going to take my sketch. So okay, so what happens here then is it compiles everything, and it takes forever. So it goes through, compiles absolutely everything, as you can see. Then it gets into the I'm trying to upload bit. That's fine. There is a warning somewhere. Can't set S clock period. Check. Well, I don't know, but it worked anyway. And eventually it said, "Yeah, I've done it." Now the thing is, though, you can't just go and press that button there, the right button to say upload, because if you do that, it says I can't do it. In fact, let's do that now, and I'll show you exactly what it says. I'll speed this bit up. Right, so what it says is, look, using COM15, because that was the last COM port I used in the Arduino IDE, even though I haven't actually got one specified at the moment. So what do? Well, there's two ways around it. If you want to upload here, you have to press the Shift key and watch what happens to that little message over here. Instead of saying upload, it says upload using programmer, because that's what that device is, that USB ASP thing. Okay, or you can say sketch, and I'm going to have to switch over to my monitor briefly. So what you can say then is sketch, upload using programmer, Control-Shift-U, which sounds a lot to remember, doesn't it, really, considering you don't do this very much. And it will use that device quite happily. But I think I prefer when you just hold down the Shift key and hover over that upload button. So there we are. That's just something to remember if you're going to use one of those. But it really is easy to use it, and you can upload all sorts of things. It's one of those things you ought to have in your kit, really, because they're quite cheap. They're about, the whole thing is about $5 maybe. So this, let me just unplug all this. Yeah, look at that convoluted mechanism I got to get a micro USB socket and plug down to a mini USB, down to a full-size USB, to a connector to plug in that. That should really go into my hub, but because I'm filming I can't put it over there. So there we are. Anyway, so this device, as it is there, with this long cable, and you will need extra, although some do come with it, this thing here that converts the 10 pin here to a 6 pin here, and this would normally, this end here would normally plug into the 6 pin ICSP of an Arduino. Well, of course, on here, stupidly, I put a socket because I just thought it looked nicer without thinking, oh, hang on a minute, I can't plug it in now. So yeah, so if that had been a socket on there, I could have plugged this directly onto it, which is what I do, of course, with Arduino stuff sometimes. But anyway, all that will cost you about $5, and it's one of those little kits that you just need in your, well, toolkit, really, for moments when you do have to use it. If you ever want to put a bootloader back onto an Arduino, for example, that's what you'd use one of those. Okay, so just because I enjoy watching it so much, let's plug this back in. So that's on, and that's blinking away quite happily. Yes, it was quite a relief when that did. Oh yes, by the way, the USB socket. Does the USB socket work, you say? Well, let's find out. Let's unplug it from all this and plug it directly into here. Yes, it does. But again, it's only power, isn't it? But considering I had to design the footprint for this USB socket and solder it in, all the rest of it, I'm quite pleased that bit works. What I'm not pleased with in the slightest and in any way, shape or form is the soldering quality of this. This is, it's just appalling, quite frankly. So what I might do then is, because I've got plenty of these boards, I might get another board, and of course I've got more of these chips, and I'll use the 0.7mm solder right from word go and try and do it that way, because I don't see why this should solder on here any differently to that practice board that I had, and that was the whole point of doing it, so you get a bit of, well, practice, and it should just be swimmingly done. Interesting, isn't it? Right, that's as far as I've got at the moment. Next thing I've got to solder on is the 2 EEPROMs and the real-time clock and crystal and stuff like that, and get all this up and running. Cool. Speak to you later. Okay, so that was initially quite good and encouraging, the fact I could get the flashing LED and everything. You notice there isn't actually an LED on there at the moment. Where it says DS1, there's nothing. And there's a good reason for that. Unfortunately, I've had to stop work on this now because there was a design error, which you can see by this grey cable on here. So the I2C bus, basically, serial clock for that, was mistakenly connected to the serial clock, which is down here. I'm just about pointing to it. I'll zoom in a little bit and you can probably see things a bit clearer. Okay, let's have a look at the actual quality of the soldering. I did in fact go over these connections here again with some solder wick, and it worked like a dream, frankly, but I did need to use a much hotter and bigger tipped iron. Then it worked brilliantly, and the Soldamop solder wick that I used, which most certainly is not cheap, I was surprised how expensive that was. It was beautiful. It's got flux impregnated and everything, so it really worked nicely. So as you can see, they're quite clean at the moment. These other EEPROM chips on the right hand side over here, they were much easier to solder because, well, the chips are spaced, the pins are spaced further apart, aren't they? So that was quite easy, even though this one here is in fact slightly misaligned. But actually that all sort of pales into insignificance really, because as I say, the pin 28 right at the top here wasn't connected to anything, and that is the clock for I2C, and everything was connected to the serial clock, which is that bottom right hand corner down here. So when I connected all this up and tried to get it running, I just wondered why I wasn't seeing anything on the I2C bus. So one thing led to another, and a bit of investigation and looking at chip pinouts and goodness knows what, and I thought, surely not. But yeah, anyway, I've spoken to Dr. Peter, and he says, oops, and he's going to correct that in the PDF version of the book. Of course, the printed version will be errored still for some time, I would imagine. But what I've done now then, just to prove that this would have hung together, is connect the I2C bus, the clock, that grey wire there, so pin 28 at the top. I've connected that now to where we were having the serial clock down here. You might say, well, doesn't that fix it? Well, unfortunately not, because down on the left-hand side then, so over here in your picture, there's a serial clock that is in fact required when you program the chip, and that's now connected to the serial clock of the I2C, if you see what I mean. So that's never going to work. Now, admittedly, I could probably hack the circuit board here and get it to work, but frankly, there's no point. It was, at best, it was only ever an academic exercise. So I've decided just to stop. But just to prove that my little hack there does now detect all the I2C bus stuff, let's go over to the code window. Right, this is the code for the hex scanner on the I2C bus. It's something I wrote years and years ago, probably, I don't know, 3-4 years ago, and I was really pleased with myself getting this working. Basically, it scans all the hex addresses on your serial bus, and I was quite pleased with that, and I thought, oh, I wonder if anybody else would find that useful, only to discover, of course, that every other bugger's done it as well. It's one of the first things you do, I suppose, isn't it? So there we are. Anyway, I was still happy that I managed to do it. So what that does is scanning all the hex addresses now on the I2C bus, and the result, if I bring up the IDE debugger, this one here, serial monitor, there we are. As you can see, it's going around in a continuous loop, but it's found all these things, 51, 53, 55, 57 and 68. So let's have a look. What would that be then? So we've got two EEPROMs on two different addresses, probably 51 and 53. We have the serial clock. That's probably on 68, if I remember rightly. I have no idea what's on 55 and 57. I've no idea. No, nothing else is connected to that board. So according to this, we've got 5 things on the I2C bus. Unless, of course, the EEPROMs... No, the EEPROMs are not addressable by 2 addresses. You can change the EEPROM address on this chip. But anyway, the point is, it's working. Okay, the I2C bus was doing absolutely nothing before that. It says scanning, nothing found, scanning, nothing found. And it probably took a good couple of hours to work my way back. And, you know, I think, what have I done wrong with my soldering and things like this? But it luckily wasn't. Okay, enough of that then. So that's where I've got to with the surface mount. Oh yeah, that resistor that you're probably looking at thinking, what the dickens is that there? That little resistor I've stuffed in there, this is the real-time clock. The DS, what is it, 1337 or something, whatever it is. That needed a pull-up resistor on that pin to get any kind of output on it. Oh, and also you can see pin 3 just over there, pin 3. I've raised the leg off the board because that was another mistake. In fact, I haven't told him about this yet. I better tell him. That was the output for an alarm, and he's connected it to VCC, so it wouldn't in fact cause a short if you ever put an alarm on that chip. It would just short the thing to ground. Anyway, these are now, interestingly enough, you see, now this is important, really, isn't it? When you're doing, well, effectively prototyping like this, and he's a skilled PCB designer, right? I've just, you know, stood on his shoulders to hack a few bits around the edges, but he's a skilled PCB designer, and there are now, what, 1, 2, at least 3 mistakes on here. Mistakes of the type that you couldn't send it out to production. They're not easy things to fix. They would require a redesign. When I went onto the PCBWay website, just to see how much it costs, you know, to have 1,000 or 10,000 of any board made, a little pop-up window comes up and goes, we suggest you get a far smaller amount first just to prove that your prototype works. And now you can see why. Even the best can make mistakes. Or you might come to a different design decision, of course. Having got the board and made it, you go, we should have done this, or put a different socket on there, or perhaps even chosen a different component. But the point of all this was for me to make up a surface mount design PCB using KiCAD, which, as I say, I used Dr Peter Dalmaris's board as the starting point from which I added a few bits. And from that point, I think, yeah, it's worked. I mean, I've managed to solder on that USB socket over on the left-hand side there without shorting anything out. I've soldered on the EEPROMs. I've done the microprocessor with the flashy blink program. That was all good. And everything else just sort of worked. So, great. Even if this hadn't had any design errors on it at all, what would I have done with this board? Good question. I might have used it in something, maybe. But it was more an academic exercise, wasn't it? So no harm is done. Right, that's that. Now let's talk a little bit more then about the other things surrounding this surface mount soldering exercise. Now, I moaned a little bit about the new solder that I'd bought, the 0.3 mil. I think it was 0.3. Yes, this stuff here. Because I wanted something finer to work with, but I'm particularly unhappy with this. Now the thing is, I bought it on the basis of 4.85 out of 5 star. Yeah, look, see that recommendation there from 75 people. So I thought, well, it's got to be okay, but frankly, I'm not. And there's one particular review, only one though, out of all those people, that frankly could have been written by me. And this is what it says: bad. Yeah, telling me. Not very good. No rosin in the core. Well, I don't know if that's an issue or not, because I had loads of flux all over my board. You need a very hot iron. Well, even with a hot iron, it flows. But weld looks dull. Yeah, welds do look dull. And that's what alerts me to the fact that that's what lead-free solder looks like. It looks like it's a bad solder joint half the time. So that could have been written by me. That's my experience, but that's one person out of 75. So I don't really know what's going on with that solder, but I'm not really happy with that, and I'll probably have to replace this now. What I do with this, well, not sure. We'll think about that, because I won't be using it, that's for sure. Okay, second thing, the practice board that I bought, a couple of, that was brilliant. That really did give me confidence that I could do stuff, and it really worked well. Nice. Yeah. And this is my hot air gun that I bought from Amazon. It's in my shop front on Amazon as part of an affiliate link. It's the what is it? I can't even read that. What does that say? Yihua or something? Anyway, 959D. You can get different brands with that number on, so I don't know what it means, if they're all clones or something. But this was an absolute godsend. You don't need it for soldering stuff on necessarily. Lots of people say don't bother with a hot air gun to actually solder things, but when you want to desolder things, my goodness, it was this a godsend. Now I'm using here at the moment one of these nozzles. You get about 6 of these nozzles, and this square one just happened to fit over that chip rather well. So when I was desoldering that microcontroller in the middle there, this thing sort of fitted over the top, and it really melted that solder around the edges rather nicely. Frankly, I've absolutely no idea how that AT Mega 328 survived all the abuse I gave it. I mean, it was desoldered twice and then resoldered, of course. So the heat that went in there, I don't know how it survived, but survive it did. Right, and I'm also looking for a bit of help. This came with that hot air gun, and I've no idea what it does. There's a screw thing there. There's this tiny bit of springy metal. This is quite springy. I thought, is it some kind of stand? But there's nowhere for it to go on that machine. So I don't know what this is. Any suggestions? Clean ones, please. Gratefully received. I mean, does that somehow screw behind there? But then what is? I've no idea. I've tried every single way. There's no holes on the machine to screw it into. And there's a couple of spare screw holes, but it looks like it should be something to rest a hot iron on. But then if that was to go behind that screw, say, where does this bit go? Unless, of course, that is just a spare bit to put into your workbench. Maybe nothing to do with the hot air gun box itself at all. I don't know. If you know, please let me know. Right, and here we have 2 containers made out of high density something or other, polyethylene maybe. Because I saw a video on surface mount technology, soldering and desoldering and getting rid of the flux, and so I bought a whole huge bottle of isopropyl alcohol. Very good it was. Bought that from Amazon, quite cheap, and it was about 10 quid for a litre. And the thing about the video says you pour it into one of these bottles, and it has this special pump action. It's really meant for nail varnish and stuff like that. And so you pump it down like this, and stuff comes up on here. You can either put it onto a brush or whatever, and it all works great. Except this one does not work at all. Absolute rubbish. I mean, that cost about, I don't know, $2-3 maybe, something like that. No good at all. Won't be recommending that. So I then looked around for a real one, and this is it. Now this is a branded one, and the brand, I think it's Mender, is it? What does it say? Yeah, look at that, Mender, right? And these are all sold by the the big boys, RS Components and Mauser and people like that, and they are ridiculously expensive. I mean, it's just ridiculous. This bottle cost $16 or thereabouts. I mean, you can see why I bought the cheap one first, can't you? And if it had worked, I'd be singing its praises. But as it didn't, I looked around, and this was really the only alternative. And Mender do say on their website, don't be fooled by those cheap imitations because they don't work. And they're right, they don't. Whereas this one works brilliantly. I'll show you what happens. Let me get a horsehair brush. Right, so this is a horsehair brush for getting rid of flux. And if you look at this board underneath and everywhere, so right, I know it's upside down, but at least you can see that it's pretty clean, isn't it? There's no flux anywhere. And the top similarly, especially around those microcontroller chip legs. So if you see here between all the legs of each of those chips really, and all the pins and everything, there's no flux left at all. Because that isopropyl alcohol plus this horsehair brush just manages to get in there and move it all out of the way, and then you just use a simple sort of kitchen towel type thing or cloth, and it sucks it all up, and you get a perfectly clean board. So how do you do that? Let me just do a quick demo. So by pumping this, and it comes out here straight away. You have to keep the brush over the top. You pump up like that. Can you see it coming up? Look, see all that liquid in there. Look. Now that's isopropyl alcohol, even though it does say in fact flux remover on the front. Those stickers come with it. And then you get the board. Let's get a clean board to try it with. So you get a board like this, and just get in there with this brush and really stipple it, I suppose is the word, isn't it? So you get in there and clean all the flux, and it dissolves the flux really, really well. And then just use, as I say, a cloth or something just to wipe that off. And well, that will be your result, really. Same as what that is at the back there. Absolutely worthwhile. Well, the brushes they're about, I think they were about £3 to £4 for a pack of 5. They're definitely worth it. As I say, that even now, the cost of that bottle makes me wince, but I had absolutely no choice but to do that. And finally, I said the solder was rubbish, but this solder holder, 2 reels, you can get them in single versions as well. They go on these little spindly things, right? They're just held in there by gravity and can't fall out on the left or right. They have these little guide eyes here, so you can angle these up or down depending on where your board is, where your soldering iron is, and things like that. This is absolutely fantastic. It's so much better than what I used to have. I used to have it, funnily enough, in the base of this third hand here. I did a video on this third hand. Must be 3 years ago now. I used to have it sitting in the bottom and then running up to one of these alligator clips and through the hole there. So, conceptually it was all much the same, but this one really is fantastic. I'll put a link down in the video description for that. Yeah, and it's really solid. I mean, it's excellent. Love that. Right, that brings an end to this video. I think it's successful, even though there is an issue with the PCB. That I don't think that matters at all, quite honestly. As an exercise, it worked great. Surface mount technology is not the easiest thing to do, but I think with practice, it definitely comes easier. So, yeah, all in all, it was a great exercise, and I shall hopefully design a few more PCBs that incorporate SMD components rather than through hole from now on, using KiCAD, of course, we hope. Okay, that's it for now. If you want to put your comments down below, there are lots of links to all the bits and pieces that I've spoken about. There'll be links down there. As I say, you can look around and see what else there is. And yeah, comments, I've mentioned that already. If you think it's worth a thumbs up, give me a thumbs up. That helps me tell YouTube that this was a worthwhile video. And see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.